So let's discuss center of mass, just the concept level. Center of mass, first of all, is center. So center is a position, so a set of coordinates. In the two-dimensional plane, we're talking about two coordinate values, x value and y value. So they must be in lengths units, right? Something like meters. And although it has mass in it, center of mass has no unit in kilograms. It's a purely set of positions. Okay, so let's get started. I'll draw a shape. So let's just say, okay, here I have a circle. Well, it's a solid disk. All right. So the center of mass of this solid disk, which is, I assume, a planar shape, uniform density, it should be the center, the geometrical center of the disk. And if I have let me try a square. All right, a square, so the center of mass should be the geometrical center of the square, which is here, right? So if I have a rectangle, same thing. I'm assuming all these shapes have uniform density, so the center of mass is right there in the middle. Okay, so for shapes like these, we call these rigid bodies or extended objects. So these objects, their center of mass are geometrical centers if they are planar and also uniform in density. So this is easy to understand on the concept level. And what if you have something that's not really regular? Say you have this shape. Okay. Oh, it's not even closed. Okay, it's enclosed now. So you have this shape, and where's this shape's center of mass? It will be really difficult to find out. And you can also assume that the density is not uniform, and then it'll actually, we have methods in practice to find out center of mass, and we also have theories to calculate center of mass. So the center of mass of such object we'll have to discuss later. But we know that these regular uniform density planar shapes, easy, right? You can find center of mass just from their geometrical center. So that's one part of the concept for these shapes. Another part of the concept is, what about you have just point masses? So let's look on the right side. I have an XY coordinate system. So what if you have points over here, say x equal to 1, y equal to 0.5. So you have a mass here. Let's call that m1. And let's just randomly give it some 1.2 kilograms. Okay, so there's a point there. Let's put another point down, maybe a 0.5 and a 2. So let's have a bit more mass, and we'll have a bigger dot for it. So m2 equals 2.8 kilograms. Okay, I just made up these numbers. So there are 2 point masses. You can also imagine the point masses are just like these shapes, except that their separations are so large that the extent of the shape is irrelevant. It's too small to compare to the distance between the two, right? So this is that kind of idealization, or you can call them point masses. So you have 2 point masses. What about the center of mass? Okay, so first of all, center mass is related to geometry, and the second is related to the mass. So let's first draw a line. So I have a ruler here. I'll just use a ruler on the screen. I draw a line here. So the center mass must reside along this line. It cannot be on the left of this line or on the right of this line. And the second, I talked about the mass, right? So this side has more mass, this side has less mass. So if this were the center of this line, the midpoint, and then more mass and less mass, so center mass should be closer to the heavier side. So this should be the center mass, just on the concept level, not exactly. Okay, all right, so not exactly, but on the concept level, it should be closer to the heavier side than to the lighter side. Okay, so how about getting the exact calculation then? Alright, so the exact calculation, let's put down center mass calculation. So there will be an x center mass, which is equal to m1 x1 m2 x2 over m1 plus m2. Alright, and the y center mass is equal to m1 y1 plus m2 y2 over, again, mass m1 over m2. So let's do this. Have a ruler, so why not? So let's analyze the units. On the top you have a mass times a length, same thing for x. So mass times length is a meter times kilogram. And on the bottom you have kilogram. So if you divide the units, then you only have meter left. Although mass is involved, its unit is not. Just the quantity, the relative quantity. Alright, so let's calculate this. We have m1 1.2, 1.2, x1 is 1, m2 is 2.8, and x2 is 0.5. And let's also complete this side. 1.2 times y coordinate of the first one is 0.5, 0.5, and the 2.8 times the second one's y coordinate is 2. And the bottoms are 2.8 plus 1.2. Okay, so 2.8 plus 1.2. Okay, so the bottom is actually 4. So 1.2 plus 2.8 times half, 1.4. And the bottom's 4. And this side, let's do this side as well. So this is 0.6 plus 5.6 over 4. (2.6 over 4). And the y-axis 6.2 over 4. So we can calculate this even by eyeballing. So 2.6, half that 1.3, and half of that is okay. So 1.3 is 0.65, 0.65, and we're assuming these are all in meters. So I'll put in a unit. And 6.2 over 4, so 3.1. 3.1 over 4 is 155. Okay, so now let's look on the xy coordinate where this exact point is. 0.65. So here's 0.75. So this is 625. So 6.5 is somewhere over here. And then 155. So 1.5, 1.75. This is what 1.625. So somewhere over here is 155. Not trying to be exact. So let's draw this out. Oops, I guess I didn't draw it nicely enough. Okay, so there. Okay, so my initial guess was close. That was just a happy coincidence. But conceptually, I know that this center mass should be close to the heavier side than it is to the light side, and also along the center line between the two masses. So that is the basics I was guessing with. So I was just lucky I got close enough, and the exact center mass is close enough to my guess. Right here. Thanks.